We're going to get started in just one moment. I don't see our first speaker who is in person, so we'll go through the chair slides and hopefully he'll have come in by then. Shall I get started? Shall we get started? Oh, we need a note taker. I sent mail out last night but didn't get one. Who is willing to take notes? Sometimes in the past, I've bribed people by offering to buy them a beer at the farewell reception, or a drink at the farewell reception, but I'm not even sure if that's relevant. But anyway, who is our note taker? We need a note taker. Or from the remote people. Could someone identify themselves as a note taker? Note taking is highly virtuous, like privacy. And thank you. Okay, thank you. Okay, jump into Hedge Doc. Thank you so much. Okay, so this is the Privacy Enhancements and Assessments Research Group session. You're in the right place for the Privacy is a Human Rights Party, and I mean party in the sense of a party. I'm Allison Menken. I'm one of the co-chairs. This is the first time I've been in person chairing this. I'm going to start with the note well. We expect you to actually take a few moments to read it and to be aware that it is binding on you. It is not, this is there on purpose because we need it. So please I'm going to wait till 11:33 before I change the slide. Give it a read. It does actually matter. The guidelines for conduct, the anti-harassment policy, the disclosure of rights in material that we discussed today, process information. We do have an IETF privacy statement, and we do sometimes make public records of these activities, so be aware of that. I'm going to move on unless someone tells me they absolutely need more time to read that. Okay, and then there's some meeting tips that have been developed. One thing to note, the session's being recorded. If you're in person, please use the MeetEcho Lite or the on-site MeetEcho to sign in and identify yourself and get in the queue when you want to come up and make a comment or ask a question. If you're, don't turn your audio and video on unless you are during the session, and for the remote speakers, that will be handled automatically. So, okay. And we have a really good agenda today. We haven't actually got the last item on it. We have the slides for it. So it'll be a little tight. We've given 25 minutes to each of the talks, but that includes questions and answers and discussion. And we also have a 10-minute teaser about an interesting activity on source privacy. And that will come at the end. And I apologize for it not showing in this agenda, but we do have your slides. So our first speaker is in person, Arturo Filasto from UNI. And I'm going to switch to your slides. Sorry? I think so, sure, why not? Does anyone object to another recording going on? Backup recording, right. Okay. Okay. And let me confirm my selection, and I'm going to give you, yeah. Oh, you want to use, I don't know if that's going to, I don't have the right USB slot, but this clicker works.
I have an adapter.
I can give you control of the clicker.
Okay. Does it have a luminescent thing? Like a laser? Ah, nice.
It does, yeah.
Professional.
Actually, would one of my co-chairs give control of the clicker to Siobhan, to Arturo?
Nice.
Thank
it
you.
works.
It is my first time, and I practiced, but a lot of things have happened since then. Thank you. Okay. And I think I'll set a timer for
This should have a
15 minutes just to give us, awareness so that we should start thinking about Q&A at that point. All right. Go ahead. We're happy to have you here.
Okay. Hello. Hi, I'm Arturo Filastò. I'm the founder, president, executive director, and CTO of an organization that's called UNI, OONI, not to be confused with OONI.com, which makes pizza ovens, which as an Italian, honestly, I find a little bit insulting because, I looked on Reddit at their pizzas and they don't look, they put pineapple on their pizza, like what? You like the pineapple? Okay, nice. Very nice. Very nice. Perfect. So this is a extended play version of the original presentation that I did at the Armor Working Group. So it contains a few more nuggets of interesting insight, let's say, that comes from us measuring and understanding encrypted client hello deployment. And it's really just about, that's the point of the organization that I run. It's really about just observing openly what's happening on the internet in the specificity, and try to see how, as an example, encrypted client hello has the potential of strengthening end-to-end resilience. And so, I start off by talking about the why. So the why is there is this RFC, which honestly I don't remember what it was, but there's a request for comments which talks about this particular TLS extension, which is, and by the way, if I'm boring you with stuff you already know, like just tell me next, and I can go next to the next slide or skip or whatever. But anyways, the issue with the encrypted client hello is that, with the TLS handshake is that there's this particular extension called the server name indication, which includes in the clear the server name, as you would expect, to be able to, in some way, disclose to the terminating TLS endpoint which particular host name you are interested in establishing a TLS session for. And as we can see here, there's a smiley face, which is actually not a smiley face. It's a sad face because it's two dots and a open parenthesis. So not good. We don't like that. So what we do, we take and we make encryption. So encryption, in particular, we take HPKE, and I didn't remember what this standard for, so I had to look it up this morning. And it stands for hybrid public key encryption. So it's basically, I don't know why it's called hybrid, honestly. I didn't study it that carefully. That's why I hired Michele Roux, which, did he give me his badge? Ah, yeah, there we go. Nice. So I have a cryptographer in my team who's called Michele Roux, and he consults for me. He's a very expert cryptographer. Like if you want a serious cryptographer, you should call him. He's great. Zero Sigma protocols. Anyways, stuff I have no idea what it is. But anyways, there's this hybrid public key encryption, which I'm sure you're familiar with public key encryption. You have a public key, private key. Alice, Bob, they want to speak. Give the key to Bob. Bob does. Anyways, there's a situation where you disclose some information publicly, and then there is some information that is kept private, and through this information you're able to securely end-to-end encrypt the communication without certain properties, but you know, it's good enough. And so that's the start, right? It's like, okay, let's take this thing that exists already, HPKE, and let's use it to encrypt the server name indicator, right? That was the goal. We want to take server name indicator encrypted. That's why it started off as ESNI, right? That was the original, you know, I looked at the revision history. It started ESNI. Let's encrypt the SNI. Then at some point along the way, it became, okay, let's encrypt the whole client hello. Sounds great. Why not? You know, let's encrypt more things, you know? We can encrypt additional things. And so then it became encrypted client hello. Makes sense. Like, I think it's a lot of sense. And I don't know, I just wanted to highlight 2 points regarding the ECH config, which is the means through which this particular cryptography configuration, as well as other additional fields, are used in order to establish this TLS handshake. And they are public name, which basically says what should end up inside of the outer client hello, because middle boxes exist on the internet, right? I'm sure you know this. I've seen that a lot of people talk about the rights of middle boxes, and you know, I'm all in you with that. You know, anyways, let's not talk about that for the moment. So there needs to be some kind of outer SNI so that middle boxes are happy, and that is the public name. The other key point here is that there is this, you know, hand wave thing of like, it needs to be distributed out of band. And in practice, it's DOT or DO, which sounds great. I mean, it's you use what you have. Makes a lot of sense. The main thing I wanted to focus on was this private public name, which uses the verb should, which is interesting because it's a verb that has a particular meaning inside of IETF. And it means that you can, but you can also not. Anyways, moral of the story is we now have encryption. That's great. Hooray for encryption. The plain text, it used to be a semicolon sad face. Now it's an emoji. We have like, what is it? UTF 16 characters, maybe even. And another point that I wanted to make is that there's this old saying that privacy likes company, right? So the more people you have using a particular thing, the better it is from the perspective of privacy. And in reality, what we see in the data that we did by doing a wide scan of, I don't know, I think we did, I don't know, we took the Tranco list, we took many lists, we glued them all together, we got several million domains, Cisco's data, took all the data, put it all together, stitched it together, did a huge scan, I should say, an excellent master student, Ben, did the excellent work, did this chart. The scale, this black, as far as he told me, black means 1, but I don't know, maybe that scale can use some improvement. But the point, the bottom line here is that the main deployment of ECH is Cloudflare still. But, you know, maybe it can be fixed. Next. So how does our test work? So our test got developed, well, we initially developed, then it got improved by DeFo, which I saw this gentleman leave today. I don't know why he didn't come. I wanted to give some creds when creds are due. And Uniprobe is the software we develop, and it runs on the internet, and it basically does some tests. This is part of our experimental test suite. So it's work in progress tests. It's stuff that is not yet ready for prime time. We're still working on it. You know, but what is great is that now we can measure where ECH works, fails, or is deliberately blocked, which is the goal. That's what we want to try to figure out. Like, what's going on in the cloud? You know, the man shouting at the cloud, you know, what's happening in here? You know, this is the black box, and we're trying to figure out what's in this black box, you know, and we probe with our little tentacles, and then we make it available as open data. We have hundreds of terabytes of data that, courtesy of Amazon, okay, I mean, I don't want to say blasphemy, but they gave us free S3 storage. So thank you, Amazon, for giving us free infinite S3 storage. We're still not using it all. Like infinity, as far as I know, it goes on. So we have hundreds of terabytes. If you want to mirror it, by the way, there's a command. It's a one-liner. You just go to docs. I should have put a slide here about that, but it's easy. Docs, D-O-C-S, .ooni.org. And you can find the documentation there on how to mirror it. It's like a one-liner. You just need the AWS CLI. What's the point? So I wanted to present some work. So the work that I wanted to present was this evidence of adversarial interference, basically. Like the point, the key finding, I guess, is that we found that a particular, because it's nice to measure stuff, right? Like I usually, when people ask me how you measure the internet, I usually, I tell them, unfortunately, you can't just take a ruler and measure the internet. I wish it was so easy that you could take a ruler and just go there and be like, oh, let's see the internet, you measure it. Can't do that. You need, it's a little bit more complicated than that, you know? And this is a nice, very nice ruler. I got it in Japan. It even like folds, very nice ruler. I carry it everywhere. But I can't use it to measure the internet. We can't use it to measure the internet. We need to do analysis of the data that we collect such that we are able to understand what is going on. So like step one is collect the data. Step two is actually look at the data. And when you're so busy, like, I don't know, running everywhere, like trying to collect the coin, I guess that's also another problem, but separate problem. You oftentimes don't have time actually to sit down and carefully look at the data. And so this is an open problem for you, everybody here. Like this is what we see in the data. We see Greece, which I'm sure you know from TLS. Greece is this thing that Google pushed out a bit, you know, aggressively, let's say. So they said, you know, let's go YOLO. Let's just try out something, and then we'll try and figure out how to standardize it later. Okay, pros and cons. I'm not expressing judgment. Greece was also done as the first step for ECH because it was like, are these middle boxes indeed a big problem? And so that was the first step. Is like, let's make middle boxes happy. Let's put Greece. Let's make sure that if they break, they're not breaking in a way that is causing issues. So Greece basically is fake ECH. None is no ECH. Real is real ECH. Greece and real should look identical in theory on the wire. And they do. Like if you look at the packets, they look the same because entropy is indistinguishable from entropy. And what we observe in the data is, as you would expect, that Greece and real look the same. But that then what is the key is that two things. One, this is Russia, by the way. None means there is no ECH. If there's no ECH, there is no blocking. If there is Greece, which is good enough because it's anyways the same as real, we see no blocking for the outer SNI of cloudflare.com. So that's the key takeaway here, that it's a combination of the two things. And I see that I am running low on time, so I better get going. The other thing that I wanted to raise awareness on is what the effect that this had on users. So users went to forums and they started saying, because it basically put the Russian government, ISPs, whatever, in a position to basically have an out-out. They could either block everything or block nothing. And so what they did is here, they blocked everything. So even sites that were unrelated to the sites that they wanted to block were affected as collateral damage. Again, I'm not saying it's good or bad. I'm just saying that this is what happened, okay? People reported on the forums these issues, and they were trying to disable it. Other basic things is like, in some countries, they just look at the outer SNI. They don't even bother with looking at if it's the protocol, you know, not as advanced as Russia. This is another point I wanted to make. Oh, they broke. That's a pity. Okay. Anyways, I wanted to make a point about open data and research. So I did a workshop. I participated to the Internet Measurement Conference, and it was fantastic. An amazing, research community of people that are measuring the internet and are doing great work. And there were some students there that, they were offered all the data sets. I gave them access to the notebook server where you have a ClickHouse instance that you can just run queries for free. Like, no. And, they used the template that was given to them. They just had to copy the template and then put their name on the thing and then go in and run queries. And they did. They ran some amazing queries and they reproduced the same study with their matplotlib. Great stuff. Let's give a round of applause for the students. The point I wanted to make is that this happened already before. It happened in the case of Iran with TLS. Okay, and again, I care to say that I don't want to say that encryption is bad or anything. That would be a terrible thing because we need to move forward. But the point that I'm trying to make is that when Wikipedia encrypts everything, similarly, Iran has binary choice: either block everything or block nothing. So the point I'm trying to make is that don't take our word for it. Play with our data. That's our website. Here's the students. Okay, nice. Got flipped around. The internet is a complex, interdependent ecosystem. Actions in one part can have unpredictable ripple effects elsewhere. Second-order effects remind us that attempts to control the internet often deepen our understanding of its emergent, unpredictable nature. So let's make a better internet for humans. That's it. Thank you.
Okay, questions, comments? We have a little time.
No question.
There are. Christopher Patton, you're first.
Affiliation is Cloudflare. So I just wanted to mention that in some sense, I think it was we expected collateral damage when you start blocking ECH, and the reason is because ESNI was blocked the same way. So that ESNI referring to an early draft that predated Greece. It's hard to tell from the numbers. I mean, I'd like to know, like, do you think Greece helped? I think not totally clear. There is a draft being talked about at TLS about how to make Greece more effective. So if folks are interested, it'd be great to get more feedback on that work. Thank you.
I mean, what I would say is that the Greece should go not in the ECH, but it should go in the collaboration between the companies, because I think the point is that if you only have one company doing it, then, you get this thing, right? So like that it's only Cloudflare ECH, cover, defo.ee, and then all these gambling websites, people that are like using Google as an attempt to cover some, well, I don't have to read these ones, but like, I think you can read them yourself, adult content, gambling, like the stuff that, I don't know. So like, you want to go back to the previous slide, privacy likes company. So the point is that the more the merrier. So if you get the Cloudflare, you get the Apple, you get the Google, you get all of them together to agree to do the Greece or to do whatever, then you get nice privacy properties. If everybody does their own thing, then you get no privacy. That's what I learned at Tor. I mean, I used to work for Tor also.
Andrew.
Hi, Andrew Campling. Thanks for the presentation. Some good stats. Three main comments. Firstly, I think the Russian collateral damage, from my recollection, wasn't collateral damage because the regulator required the ISPs to block all ECH. So it was intentional. I'm splitting hairs, but it wasn't. It was a deliberate act to block everything rather than be selective. Perhaps more specifically, I think we need to be mindful that there are some downsides to implementations like ECH for things like cybersecurity. If you block or if you encrypt metadata, then there can be negative effects, and it's no coincidence that some of the early adopters of ECH are malware actors or malicious actors who have been moving quite quickly to use it. And then, finally, I mean, the other thing, just specifically for privacy, since your main focus was really privacy, I think we also need to remember that the privacy promise is only about third-party observers, on-path observers. You're not getting any privacy from a CDN operator, which I know Gianpaolo will go on to cover, but in this case, pick your evil actor. Is it the on-path observer? Is it the CDN operator? Who do you not want to have your data? Whether you want your big US tech company to have it is a question that different people have different preferences.
Gotcha. You ask a lot of questions, huh? Like many questions you have. So I'll start from the first, regulator. So yes, I think regulator is issue, but also, again, emergent properties of internet, like complex system, etc. I think we have to learn from everybody. When they blocked our website, exploreuni.org, we got an email from the Russian regulator saying, hey, we're going to block your website. You have some amount of time to take down this page. They had already blocked it because we see it in the data. So they notified us a bit too late, but at least you can go to website Roskomnadzor and type in, solve a CAPTCHA, prove you're human, and then you get the ability, for example, what Roskomsvoboda does, to basically say, like, basically be informed on like what's going on, right? And that's the kind of thing that we are also trying to do with the Open Observatory of, understanding this complex system and trying to understand what are these unpredictable ripple effects that occur. To the point on cybersecurity, I mean, I don't know, like, sure, there are some interests here, and, I bet there's like people that would like to, I mean, I don't know, look, let's table that one offline. That's what they keep telling me, offline. So that's offline. Move fast, yes, move slow. I was part of a movement, the slow crypto movement. I don't know if you've heard of it. We try to make cryptography that's, you take it easy. It's not so fast. It's like more down to earth, like not up in the quantums or like this kind of stuff. We're like, what you have to send a message, even if it takes light years, you can send a message. On path, honestly, this I have to pull up my notebook because I always mix up on path and in path. I never remember which one is which. Can you remind me? What's on path? Is it direct? Like, is it inline? Or is it like that you're injecting packets? Which one is it?
I think on path is just somebody who can inject packets or make changes. Yeah.
So China style.
Yeah.
China style. Okay, that's that way I remember it. Okay, so you said on path is more of an issue than CDN, or vice versa.
Can you say that in the mic, please? For the remote people.
I really don't. Oh, yeah.
Sorry,
remember it.
For clarity, depending on your preferences, your threat model, you may have an issue with one or the other. I think it's just important to remember that this particular implementation, you don't get any protection from the CDN operator seeing everything you're doing. And with in some of the other workshops this week, with the vast amount of stuff centralizing on CDNs, that gives a lot of power to the CDN operators, which is, I think, worth thinking about.
Yeah, that's an excellent point. And I think this is a point that should probably be added to the Armor working group, just to break an arrow in the favor of Armor working group, because good anonymity is very, very hard problem. Like, if you have that kind of threat model that you're up against the NSA, I'm sorry to say it in French, but you're fucked, Like, that's pretty much the TLDR. And so, what you got to do? You get owned. You know, like that's what you do. Like at some point, I think personally that depending on the amount of attention that you attract, the question is not if you are owned, but rather who has owned you and at which level. And so, you know, at a certain point, you're like, okay, whatever, you know, own away, you know, owned by this, owned by that, you know, like whatever. So that's why I remember still this thing. I traveled the first time I went to San Francisco. I was with my friend. Well, I won't say the name for privacy reasons. Chatman House Rule. I was with my friend, and I met the person that made BitTorrent. I can say that. And I remember I was talking to this person, and I was telling them about like this idea that I had of something. I don't even remember exactly what it was, but he was like, "What's your threat model? What's your threat model?" And I was like, "Dude, like, what's your threat? I don't. Good question. I had never thought about that, you know." And I was like, "Good point," you know. And so it all starts there. It starts from, and I think Nick Sullivan made an excellent point in the Armor Working Group that step 0 is terminology and threat model. And then you decide, okay, threat model, this, terminology, that, and then we understand what the language is.
I'm going to give Dirk privilege to say something.
Sorry,
about armor.
I have to step in here, Dirk Kutscher, IETF chair. We really have to be a bit more careful what we say here. So there is no armor working group. There's also no intent to establish an armor working group. What we had was side meetings to discuss possibilities of an armor research group. So they said really different things in the IETF context.
Sorry, beginner.
Welcome, though.
Thank you.
There were a couple more people who had questions. Flo, hello, you're next.
Hi, Flo Driscoll. I was wondering, thank you for the presentation. Could you go to the slide with the like Greece, real, none thing on it? So can you, sorry if I just missed this. Can you explain kind of what's going on here, particularly with like the big dip in the middle? Is it like it was being blocked and then it wasn't, and then it was? Like, can you explain any context to this?
Flo, that is an excellent question. I wish I knew. I was so busy organizing the IMC hackathon that I literally, this is fresh off the sequel press. Like it literally was done as I was preparing the, so I don't actually know. Like, this is a good question. It's an exercise to the reader. It's like, what happened here? And I can,
Your title covers the important part.
okay, I can pull up.
We will probably have to be a little bit briefer now, but this would be a really great thing to pick up.
I can
It's a
upload
great, I'm really glad you asked the question. Maybe we can do if you're both on the mailing list, we can.
I can post it on the mailing list.
Yeah.
Can I post it on the Armor mailing list?
Yeah.
Is that okay?
But also post
No,
it on,
okay.
please post it on the
Thank
PEARG
you.
email.
PEARG, okay, I'll
Yeah.
post it there.
Yeah.
Great. I send the JPEG. Can I attach JPEG? No, CSV. What formats are supported? Link,
Definitely
okay,
should
link. Link,
Flo,
okay, great.
Did you get to ask your question enough? I didn't want to rush you too much. And we've closed the mic after Nick. So Nick is up next, and then Vaibhav, I'm sorry, we had to close the mic because we actually have a talk about threat models next.
Nice.
So Nick, are you there? Flo, can you need to take yourself off the queue.
Yeah, Nick Thodey, Center for Democracy and Technology. Thanks again for presenting this. I really like your like sort of higher level thinking that we need to do about this sort of collateral blocking, and maybe we need to get a little more sophisticated talking about the second order effects. It seems like it seems like there could be some advantage in dramatically increasing the collateral blocking, right? If the sensor has to block literally everything, that's a much higher cost thing than just blocking Cloudflare or just blocking Wikipedia, even if those things are larger than the particular target they're going after. But maybe it would be useful for us to know, like in a little more sophisticated way, what that extra amount of blocking matters, both for the network interference agent, the potential sensor, or for the user. So just if you have details about that, or if people want to do research on that, I think that would be great.
I agree. I very much agree with you. I mean, one word of caution I should put out there, though, is that the lesson learned, I think, is that there are, because it is a complex system where there is interdependencies between many different pieces, you know, it's like a pond. You take a stone, you throw it in the pond. You can't exactly predict I surf, so I studied also a little bit of meteorology. I studied a little bit of waves, hydrodynamics. It's really complicated stuff, and you know, you kind of guess a lot of the time. You know, in meteorology, there's this notion of ensemble forecasting, which is a French word. It means you take many different models, you put them together, and then you get something that's a closer approximation to what is reality, right? I don't know, like if everybody hoards their own data and keeps it private, then you can't do ensemble, you know? You just do solo. You know what I mean? So that's maybe food for thought.
Thank you. That is a great kind of charge to the group. And please, let's discuss. Please join if you're not on our mailing list, join and let's discuss here.
I shall join. I will read the note well, and I will try to get the tutorial for it. Thank you.
Okay.
Thank you.
Great. We have our next speaker, Kyle Hogan. You're there remotely. And let me get your slides for you. Thank you so much, Arturo. That was really fun. Okay, so or is one of my co-chairs doing that? Because I don't have controls. I'm getting all the slots from requested media are already taken. Is it something that one of you
might need to close the first presentation?
Yeah. We should be able. Oh, here we go. I got it. It came back to me. I'm going to put your slides up on the screen and then give you control, Kyle.
Yeah, I see them coming up.
Here we go. And actually, could my yes.
You should have control now, Kyle.
Cool. Thank you. All right, so I'm Kyle. As advertised, this is the threat models talk. However, this talk was actually my PhD defense, and so it is modified from its original format and has been reformatted to fit this working group. So if you're seeing the number of slides, we will not be going through all of those slides. I left extra slides in case people are interested in things I didn't get a chance to talk about. Maybe as less as advertised, this is actually going to be a talk about ads, surprise. And I think, the first thing that people are going to be wondering is, okay, what is a talk about advertising doing in my privacy research group? And I think the second thing that people might be wondering is, okay, well, I'm going to use an ad blocker. I don't really like to think about ads. And so the beginning of this talk is going to actually be sort of my motivation and why I think talking about privacy for advertising is important and why I think there should be more research in this area. And kind of the reason for that is that when you are using an ad blocker, you're probably really used to seeing all of these pop-ups come up. And one thing that's kind of tends to be in common for them is that they're all going to kind of remind you that their websites are actually ad supported. They're saying that these ads that you're trying to block are actually what is paying for their content, paying for their journalism. And they're going to ask you to pay them a subscription fee as an alternative to actually seeing the ads. And then kind of the other thing that happens here is, monthly subscriptions. And generally, this is a well understood mechanism to avoid seeing ads. The other one is kind of web monetization, if people have looked into this. And this is more of a streaming micropayment style way to say, I don't want to see ads, but I still want to pay the creator of the content I'm consuming on the internet. The common thing between both of these is that they're actually a way to sort of pay money or see ads. And this is fine, but we're starting to see more kind of alternatives in this space that are subscriptions to kind of social media websites. And we're not as happy with these. These are maybe a little bit different than the subscriptions we're more used to in the past. these are actually kind of asking you to pay money or to consent to the use of your personal data for advertising, which is like slightly different than pay money or see ads. And I want to kind of make that distinction here. These are sort of subscriptions for privacy and not actually subscriptions for sort of like funding the content. And like, it's okay to say I want to pay money and not see ads, but it's not okay to ask people to pay for privacy. Everyone who's browsing the internet has a right to their privacy, whether or not they can pay for it. And actually, advertising is sort of the bottom line here. The average person who is browsing the internet is going to be sort of on an ad-funded model. And because of this, whatever degree of privacy we can provide for advertising is going to be the average person's experience of privacy on the internet. So this is kind of my motivation for working in this space and why this was kind of the topic of my thesis research. All right, I'm gonna just kind of spoil the main points ahead of it so that we can focus in on the stuff that I'm covering here outside of kind of like everything that was in the original talk. The real like takeaway from this is a high level talk that's intended to sort of direct future research and highlight some pitfalls that we run into. So the top level takeaway is there isn't really going to be perfect privacy for advertising. We're not going to be able to leak no information. And so we're starting to reason instead about like what information might be contextually appropriate to reveal in this setting. And that leads us to this like information leakage is a very theoretical way to reason about privacy. It's one way to reason about privacy, but it isn't going to guarantee you normative privacy. It's not going to get you what end users want and whatever they're comfortable with. And so that's one of the refocusings we want to do in this talk. And the final one is that most theoretical privacy guarantees are actually about individuals, whereas advertising really actually focuses in more on groups of people or advertising audiences. And thinking about the privacy of people sort of as a collective is something that's been missing in most work on advertising privacy. Okay. Again, like we're talking about the fundamental leakage. We're not talking about the fact that there is way more leakage happening right now than is necessary. And we'd really like this to just help guide future work and avoid common pitfalls in the space. Okay, so privacy for advertising. I've been saying privacy is information leakage, the sort of like high level definition of that. It's just that some party is going to learn some new information about another party as a result of that party's participation in the protocol. And to put that like concretely for what we're looking at here, we're going to say that information leakage is when some advertiser learns new information about end users as a result of their sort of participation in the advertising protocol, as a result of them seeing ads on the internet. Okay, the context we're looking at is actually, if you want to imagine kind of the entire advertising ecosystem as this perfect, ideal, zero leakage advertising, like we designed something great, it's still going to have this input-output behavior. And what we mean by this is we're saying, okay, like people are trying to do on-device ad targeting, that's going to be really private. Maybe you have differentially private metrics, that's going to be great. But at the end of the day, you are still actually taking in these audience descriptions from advertisers and outputting metrics on how these ads perform for those audiences. And we're analyzing the leakage of that. And here, we're focusing on the top part, the advertiser, and we're not focusing as much on sort of the ad networks who are actually running this protocol. Okay, so the question, what new information are advertisers learning from the metrics on their own advertising campaigns? Sort of like what is even like a well-behaved version of this protocol going to leak about end users? And when we're gonna walk through this, as you're a user, you're gonna be browsing the internet, you visit some website that's displaying ads, that website is gonna send some data to a targeting model, and it's gonna pop back an ad. This is kind of how people usually describe it. The missing piece that we're like looking at here is, okay, how does it decide, like, where does this ad come from? And the ads come from the fact that these advertisers are going to submit advertising campaigns. And these campaigns are going to sort of be composed of some audience description. Here, our advertiser really wants to look at pasta enthusiasts. They're a pasta company, and they're trying to display their ads to people who just really love pasta. But one thing they're not sure about is actually like what kind of people might be most interested in it. So they're like, all right, we're going to show two ads. One ad is sort of a family-focused ad talking about feeding this protein pasta to a kid. And the other one is more of like a date night ad for couples that maybe don't have children. And they're going to try to run a sort of an A/B test and say, well, is like the kid focused ad or the kind of the couple focused ad more successful for them? That's what they want to do. And to do that, they're going to say, okay, like based on what this user who showed up, we think they should see the ad with the child in it. So they deliver that. And then maybe that ad was actually great. Maybe you read it and you're like, oh, this is so good. I'd love to go and buy pasta. And you do that, but you do that on kind of like a different website. So you go to some other website, maybe Instacart, and you buy the protein pasta as a result of seeing this ad. That Instacart website is going to report back. And they're going to say, hey, some user bought the pasta. The website who displayed the ad has also submitted a report. And then these two things are sort of linked to each other or attributed, where the conversion or your purchase of the pasta is going to be tied to the ad that generated that conversion. In this case, we're looking at like a last touch, or they're giving the credit to whoever the most recent advertiser was. And all of that data across many different users is aggregated up and submitted back to the advertiser to, in this case, indicate that this kid-focused ad was way more popular than the couple-focused ad. And advertisers use this to sort of like guide their future campaigns and things like this. All right, so we rotate this around, and that's kind of our like image from before. We're not going to really deal too much with the inner workings of this. We're going to instead focus on how it actually like embeds information about users into the metrics data. The two kind of like main areas where this happens are in targeting and in this like conversion environment. And what I mean by this is when ads are sort of selected to be shown, they're going to try to pick the most relevant ad for you. And I want to stop here and say this is true for targeted behavioral advertising that's going to use data directly about me, but it's actually also true for contextual advertising. Contextual advertising is still trying to show the most relevant ad. It's just using data from the website instead of directly about me. But both forms of it are trying to actually kind of embed this feature into which ad was shown by picking, based on the information available to them, whether they think I'm a parent. Okay? And then kind of the next stage of this like engagement of like, did you buy the pasta? The premise here is that people actually are more likely to do something as a result of seeing a more relevant ad. Like if you see an ad that's more relevant to you and like you really liked the pasta ad, you're more likely to buy pasta as a result of that than if you saw a really irrelevant pasta ad to you. That's the working premise for this. Okay. And so both of those things are sort of taking this information about users and embedding it into like which ad was shown, or like which ads get credit for these conversions. And like, so the more kid-focused ad, if that's the more popular one, it's actually implying something. It's implying that this audience of pasta enthusiasts are more likely to be parents. Okay. And like, again, this is not no information. We've kind of failing our zero leakage guarantee here. And zero leakage is very strong. Of course, it's like maybe too much. However, the point we're really trying to make here is that actually kind of like the two sides of it had very realistic threat models, very realistic guarantees. Even something that was saying like targeting isn't sending any information about the user remotely and metrics is going to be differentially private, it's still kind of revealing this group information. And the focus of the paper that was the basis of this portion of the talk is kind of like, can we do something about this? Like, this seems annoying. Is there any way to fix it? And the answer we actually came up with is, like, no, unfortunately, like we really can't. This is fundamental. And the reason for that is that the basic utility, like really the kind of like bottom line of these being even a little bit useful, it's intended to embed this information. And I'm gonna I left the utility slides in, but I'm going to go through them at a very high level. The key thing here is that the distribution of users in the audience is going to persist across each of these points, across targeting, across engagement, and across metrics. And if the distribution of users sort of didn't persist, it would imply that one of these things was inverting its role, okay? And I'm gonna focus on that kind of like with this picture. So if we have our audience of pasta enthusiasts, and we're seeing that, like some of them have kids, some of them don't, but like more of them have kids than not, a kind of like useful version of targeting is going to say that people with kids are more likely to see the kid ad, which is now like propagating the distribution of the audience into the distribution of the ad that gets shown. In the case
I
that
want to, may I
yeah.
interrupt for a second?
Yeah, of course.
It'd be nice if in like 5 to 7 minutes, you're ready for questions and answers,
Yes.
Q&A, okay?
Yeah. Yeah. So propagating the ad distribution, and like if it doesn't propagate this audience distribution through to the ads, it actually kind of means it was like preferentially showing the childless ad to people with kids. Like it was kind of doing the opposite of what it was supposed to do. And this is even just like kind of what we consider the bottom line for like targeting contextual or behavioral, achieving what it was setting out to do. And so yeah, preserve the distribution. The like engagement is kind of just going to do the same thing. Again, people are more likely to like click an ad that they're interested in. The kind of a neat point for engagement is that even if targeting was sort of like at least not inverting the distribution, but not kind of propagating it, engagement is going to boost the signal here. Like if the two ads are delivered uniformly, people are still going to click the one that's more relevant to them more often. So it kind of can like re-embed the data here. The last kind of piece for this is just metrics, which typically is done with something called differential privacy that I'll cover like very briefly. But the key for metrics is that, again, it just needs to not invert the distribution. It can preserve the conclusion that some statistical tests, like an A/B test, would have made on the raw data. And if it cannot preserve those conclusions, we're going to say it's not useful. And again, like, sorry, we're going so quickly on this, but it's in the full version. The takeaway for this is really just that you can't get rid of this. If you do get rid of this, you're going to create an ads ecosystem that simply doesn't work. And that's a problem for privacy, because privacy needs people to use something. And so if you create a system that doesn't function, it won't have any users. And then no one will really be benefiting from it. The last thing I'm going to say is this detour for differential privacy, because this is the most popular way right now to do privacy for advertising, and it doesn't behave as expected in this space, mostly because we're operating on groups. So what I mean by that is that it's really intended to permit learning on populations, just not individual users. So we're saying the output that these advertising campaigns are putting out should be kind of like basically the same, whether or not my specific data was included in it. This works super well and is intuitive on like big representative studies. So the common one for this is if you do a differential privacy study and you find a correlation between smoking and cancer, you're not going to learn whether any individual smoker has cancer, but somebody who is a smoker, even if they didn't participate in the study, has like some information about them revealed, because you're going to meet people who smoke after seeing these results and say, oh, like maybe their cancer risk is higher. So that's kind of the intended differential privacy functionality. The difference for advertising, and the reason I think this is kind of a problem, is that like intuition only really holds when you have this representative sample of the population whose membership is unknown. You don't know who's in there. So I want instead to consider like a kind of different example where it's not a representative sample and you do know who the people are. And these are workplace satisfaction surveys. Everyone is used to these. You're going to get something that says, oh, please respond honestly. We really value your feedback. All the responses are going to be anonymous, and we're going to use differential privacy. So you should feel really comfortable answering. Okay, so you get the data back for the company, and oh, look, like everyone is very happy. This is great. Like 70% of people are happy with their jobs. No individual data was leaked. Like this is kind of good. But now they start doing this for teams. And if your team answers, okay, so this should be like a blue thumbs up that's not showing up, and it actually like matches the distribution of the company. Your team is, known membership. The company knows exactly who's working on your team. But you did kind of like match the company distribution. So maybe like you're feeling okay about this. However, if it comes back and actually most people on your team are unhappy, that's something you're probably not satisfied with. This was still differentially private. Maybe there's sort of 20 people involved in here and you're able to reveal like roughly accurate results. But now, you're going to go and you're going to try to say, actually, like I was happy. I would like to have, plausible deniability and say, like, keep my job from this. But really, like, somebody who looks at these results is going to actually assume that any individual member of that team is likely unhappy with their job. And this is information they did not know prior to conducting the survey. And the thing I'll leave with is that advertising audiences really look much more like this than they do like a representative sample of the population. And so when you are conducting this type of study on an advertising audience, like an A/B test, they might be advertising to like people on their mailing list, people who bought something from them in the last week. And these audiences are neither representative of the general population nor anonymous. And this, I think, raises some problems with focusing so exclusively on differential privacy as the mechanism to provide privacy for advertising. It's likely necessary, but not sufficient. All right, questions?
Okay, let's see if we've got some questions. Rohan, you're at the mic.
Hi. So what should we do? What should we do instead?
Yeah. So this is some of the slides I left in, and unfortunately, I will just give you kind of like the highlight. I won't have time to go over it here, but hopefully the slides are clear and I can answer questions on the mailing list.
The slides are available. And,
Yeah.
And Kyle, if you're on our mailing list, people can ask you questions.
Yeah, exactly.
We have Bob Beck, and then I think I'll close the mic so that we can make sure we have enough time because we have a couple more sessions, but I think there's a lot of interest in what you've been talking about.
Yeah, sorry, let me really quickly answer the previous question where I put the details, but the like recommendation that we have is like, one, you should not be doing metrics that are not targeting aware. You cannot have normative privacy for advertising metrics if you do not know who your audience is. Differential privacy is just agnostic to the composition of these audiences. And so you could have an audience that is composed in like a pretty dangerous way, and it's going to provide just individual privacy, which is just like really not enough. Or you could have other audiences, and what it's revealing is that people like to get smoothies after going to the gym and like nobody cares. And these two things are kind of identical for differential privacy. So other statistical techniques like attribute privacy, which are actually focused on like a normative notion of sensitivity, could be an interesting direction. All right.
Bob Beck, OpenSSL and other things. You've spent a lot of time, of course, thinking about your representative groups in this. I don't want to reiterate what the last person was talking about, but think about your attackers, their motivation, and how much effort they're willing to put in, and don't let perfection be the enemy of progress. If you can raise the bar so that it is not impossible for a correlation, but it's much more difficult, you're doing good work.
Yeah, absolutely. And this is actually kind of the focus of the conclusion of my thesis and the last kind of part of the talk I had to leave out. So I mentioned this like pay or okay from Meta. And I think like it's important to know that that got struck down for now, at least. But I think the other thing that people really need to think about when they're working in this space is that was actually struck down by competition authorities, not privacy authorities. And people should be really, really worried about that. When we're looking at kind of the deployment of privacy for advertising in the wild, that is getting regulated really strongly by competition authorities who do not distinguish between more privacy for everyone and less privacy for everyone, as long as it's kind of the same across different organizations. And they are heavily pushing towards no privacy for anyone. And actually, like, this is kind of the reason that these incremental efforts like Privacy Sandbox got rolled back, and we now have third-party cookies like back in Chrome. And that is, I think, not the direction that anybody in this group should be happy with, even though, you know, Privacy Sandbox wasn't perfect and it was still providing a decent amount of data. So yeah, like strong agree with Bob. Like really, I think people need to be worried about what direction this is headed in, and incremental improvements towards more privacy are, I think, in my opinion, very worth doing, even if they're not perfect.
Hence bespoke. Okay, thank you. That was really great. We're going to move on to our next talk, but I feel like we've learned a lot. Mallory Nodal is joining us, and she is going to talk to us about, I guess, Sarah, I think I need your help again.
Do you want to bring your own slides up, Mallory, or shall I do it for you? Yeah, Alison.
Are they loaded?
Yeah, there we go. Yeah,
They're in the
just bear
system,
with
right?
me.
Okay.
Yeah, I got it. Here they come.
Okay.
And let me give them to you.
And we had asked Valerie to give us
You should have them.
a picture of the state of things with chat control. And this is a really interesting policy talk that I think we need, but she'll define. Thank you so much for being here, Mallory.
Yes. Hi, everybody. I'm sorry to be with you, or to not be with you. I was there earlier in the week and then had to hoof it over to Barcelona. So I'm calling you from here. And yeah, thanks for the invitation to give this talk. I don't know that I'll need the entire 25 minutes, but if you put a timer up, then I'll be sure to not talk for too long. I've done this before for PEARG, where I think I was coming a few years ago to talk about a couple of different threats in France and other places. Though some of those countries are also implicated in this talk, but I actually went a little bit beyond chat control because I didn't know that I would have that much material. So I tried to just kind of do an overall, policy threats to encryption. I hope that's helpful for people who really want to be clued in beyond what I say today. There are a couple of really great resources. One is the Global Encryption Coalition, so that's globalencryption.org, and the other one is Global Partners Digital has a heat map of policies that at least have been enacted. It doesn't show you things that are being debated, as far as I know. I could be wrong about that. Maybe Michaela is online and can correct me. Anyway, let me dive in. All right. Right. This is just what I said. Sorry. Created these a couple weeks ago. I'm gonna talk a little bit about chat control for sure in Europe, but there's also other things going on in Europe beyond specifically the chat control legislation that I wanted folks to be aware of. I'll talk a little bit about what's going on in India, because that's also been traditionally a place where there's a lot of contention around encryption. And then lastly, since we're in Montreal, I figured I'd talk a little bit about Canada. This is not comprehensive. You'd be surprised at how many countries would like to legislate against encryption, or maybe you wouldn't, but anyway, these are the things I'm going to talk about today anyway. I also, just to do some scene setting for folks who might be new to this conversation or who aren't following it as closely, I wanted to help ground the discussion a little bit, also in prior conversations that have happened in this community in the IETF. So these are three technologies, actually. These are technical approaches to what we would consider to be a sort of encryption backdoors. One is a proposal around client-side scanning. The other two are link tracking and then traceability. And so I'm going to go through a little bit of a high level on these. I'm not going to go into depth, but just to give you a notion of what the policy proposals that appear to be grounded in a technical approach are currently around the world, at least the ones that are gaining traction. So the first is client-side scanning. This is the idea that before content gets uploaded from an endpoint, that it be scanned. And then the idea is like, well, this doesn't break encryption because going over the wire or going between the endpoints, it's still fully encrypted and it's fine. The IAB put out a statement now, I think it's been 2 years ago, that helps distill the technical objection to client-side scanning, which is boils down to, if I remember right, it's been a while since I read it, effectively an ecosystem challenge because of if you mandate some service providers to do this, there are always going to be service providers that go around it. And the internet is an open, interoperable, and permissionless innovation ecosystem. And so you'll never be able to sort of contain that entire space. So that's a problem. There was also a really excellent talk that you can, of course, watch on YouTube from IETF 122. It was an IAB open talk about why the other side of client-side scanning is this notion of perceptual hash matching. You scan, right, based on hash tables of known objectionable content or content that appears to be close enough on a sort of sliding scale to known objectionable content. And that talk from from IETF 122 and the IAB open session was about how perceptual hash matching is quite fraught, and the technology is really not very good at all. So that's client-side scanning. I bet you, of course, I made a slide about it. Yeah, so these are just like the top level points. I want to make sure I hit all of them. But yes, I've said most of this. The systemic risks point, the fourth point here, is the crux of the IAB statements argument. Of course, there are other folks like CDT, EFF, Article 19. Many other organizations have come out and talked about how from a technical perspective, there really isn't a way to contain this to only certain kinds of objectionable content. And once the technology is in place, it really creates this sort of scanning pipeline for effectively any kind of content anytime. All you need is the proper laws in place and maybe a warrant or something, which is too low a bar for redesigning an entire global, primarily secure and private communications infrastructure. The other, and so, has chilling effects and all that. And you can still hear me, right? Yep. Just checking because my phone started ringing and sometimes that troubles my Bluetooth headphones. Okay, lovely. Okay, so let me go ahead and then move on to the next, the second of the three methods. So link tracking also is something that has gained traction. Again, it sounds like a very incisive technical suggestion, but it has unfortunately the effect of backdooring encryption, which is that being able to track users, maybe for the purposes of attribution, or we were just listening to Kyle give their really great presentation on ad, tracking and conversion and all that is actually really important. When things happen in encrypted, end-to-end encrypted systems, you can't track that anymore. And so it creates a bit of a problem in a variety of different spaces. So, but however, and the TLDR, which I'm sure you can imagine, is that this does require access to message content. So, requiring this link tracking across platforms, just, it's not going to work for end-to-end encryption. Even these, unique source IDs, you can do a lot of fun and fancy free stuff with URIs and URLs, but it's not a great move. It's not a good idea. It will create privacy issues. So it's, again, another proposal that's been out there that folks need to be wary of and push against. And then the last one is traceability. So traceability is this idea that you don't care about the message content, but what you want to be able to do is essentially, it's like enhanced metadata. You want to be able to track maybe the virality of a message, or maybe the origin of a message, or maybe how many recipients have received a message. In your mind's eye, imagine a really big WhatsApp group. Maybe you don't even know all the people that's on it. So one of the arguments is, well, there's so many people on these groups, like how can we possibly expect that to be a confidential place? Like, the expectations should be different. The problem is that often what's happening is that some enforcement agency, some authority has the original message. They have the content because somebody turned it in, somebody reported it. They have the content, and then they would just want to know everyone else who's seen it. Mostly they want to know who sent it. So it seems like a reasonable thing. It seems like it doesn't break encryption, but again, it would require a complete redesign of the entire ecosystem, of the entire messaging platform to be able to enhance this metadata, which contravenes, I think, the direction of travel for privacy preserving measurements. It also just creates like a lot of different expectations for storing and for doing and reporting and all of that. So we also, from a technical perspective, sort of object to that. I'm going to speed up because we've got 6 minutes and you wanted to hear about chat control. So the main scanning proposal has been circulating around the EU for a long time now, since I think my first year at CDT, which would have been 2020. We were working on this in earnest with folks in DG Home in the EC. So It's under the auspices of the EU CSAM regulation. It would require client-side scanning by design. It would require a bunch of other things, which now I'm forgetting, and I haven't been keeping up on with various iterations of this law where it's been, but originally it was like they're going to create a European version of NECMEC, which is again like these huge hash tables of known objectionable content. They were going to sort of try to make sure there was no one platform. They were all going to have to interface and interop with this. So there's a bunch around it, but the main thing people are objecting to is this mandated client-side scanning. So politically, this becomes popular, right? We know that the presidency in Europe also changes regularly. So it's been around. It keeps hanging around. It keeps coming up again and again because it's child safety regulation is really, really popular, and it's an important thing to do. And I think absolutely from the beginning of at least my engagement with the folks working on this in European agencies, that you're sacrificing a lot of really good common sense stuff that could be done with this legislation to protect kids because you keep insisting on the scanning mandate, right? Like all that we're throwing, the baby out with the bathwater. I don't think I used that properly, but anyway, you get the idea. So what happened most recently, 2025, it's safe. Chat control did not go forward. The Danes were holding the presidency, and the one state that effectively decided, because at the sort of the 11th hour, they came out not against, but just stood aside in the vote, was Germany. There are certainly all these years, we can imagine there's a handful of states that holds, a certain strong line, and then folks in states in the middle kind of shift. And again, this is very much political. It's like which political party in that state is ruling at the moment, is child safety popular or not, and then who's got the presidency, who can get a majority, and that sort of thing. So I want to say that yes, folks are very pleased that this didn't go through very, very recently within the last couple of weeks, but I don't think we should imagine that it's going away. This is not a done deal. It never is. So it's important to kind of keep ahead of where it might go next. I bet there's a bunch of people sitting in that room right now that have signed various statements, because there are statements from cryptographers, from scientists, from data protection authorities, from any manner of technologists, from academic institutions, from, name it. Folks have put their names on things because it's very much an issue. I think we want to understand where it's going, right? So there's still a proposal in there to do scanning. It's just moved from a mandatory to a voluntary, which is, I think, pretty standard. I mean, voluntary, there's a lot of platforms out there. Not all of them are end-to-end encrypted platforms. And should they be scanning against these known hash tables? Probably, right? Please. Also, the other thing to note is that this risks making end-to-end encryption a kind of platform or a kind of technology that then is age gated. So we've talked a little bit about age gating throughout the week. I know usually this is about content, or if you are on a social media platform, if you're under a certain age, you get a different kind of experience, you get different content moderation. This is a proposal that would mean, based on your age, you are actually banned from using private communication, which is a little severe. I think we'd all agree, especially, as a parent, as somebody who's worked in education. I think it's really important for young people, who are even maybe more at risk of certain kinds of security and privacy issues, to not have access to end-to-end encryption. So something to stay vigilant about. These are all from here. I can stop at any time. I don't want to overrun your agenda. I know you guys have a little bit of AOB to talk about, but I just wanted to give folks an idea of where have other ideas come up and what's still kind of being considered. The talk I gave a few years ago about France was also similar in that it coming from a national security perspective, it's really common to think of things in terms of national security. So Sweden also was taking that approach. Their domestic intelligence powers were trying to create some legal reforms that I think this has failed because of, I'm sure, a variety of things. But one of the things that happened was Signal was saying, we will just leave, like people in Sweden wouldn't be able to use our platform. We wouldn't capitulate to this sort of demand. And then also, I think there was some tussle, as there tends to be, between services and networks. France has also a digital security law that is considering compelling on-device scanning. They also earlier this year arrested the, well, Telegram is not entirely encrypted, so we can just skip that for a second, but they arrested Pavel Durov because of, well, content that Telegram had that they weren't giving over. I think the lesson there was don't have the data. You won't get arrested. Traceability. This is actually still an issue in India, although it's less prevalent. There's still an open suit between Meta and India over WhatsApp and requiring traceability, but it still exists in the proposed IT rules. It's not entirely gone away. It's just the rhetoric has shifted, and also the rhetoric to know in India, it's not so much around child safety, it's around drugs and crime, and it gets a lot of people. I mean, just the other day, my friend did a screenshot of a news piece where people were debating this issue. Let me just touch really quickly on link tracking, because I mentioned already in Canada. So Canada was one of the places that was talking about this link tracking issue because it was related to social media and news, and not paying the news publishers for content that originated on social media platforms. But there have been a few other things that Canada's done recently. The Online News Act is the one I was talking about just now. There's an Online Harms Act, which is really similar to the UK Online Safety Act. And then the Strong Borders Act also has some lawful access provision. And that's the one that's most recently been discussed. So let me just pop on over to the last slide, which is resources. So, look these up, find the slides later. Happy to take any questions.
Thank you. We've got one person who has with a question, Dan Sexton. Two now, three now, and I think we should stop it at 3. So go for it, Dan.
Hi, Dan Sexton, IWF. So I work for the largest hotline tackling child sexual abuse in Europe. This is an area that we do have some experience in. Chat control is a catchy hashtag chat control. That's not what it's called. It's the Child Sexual Abuse Regulation. I just want to draw attention to the importance of the word regulation there. This has had immense pushback from huge amounts of lobbying in the EU. The EU Transparency Register showed that lobbying by digital tech companies is up to, this year alone, is up to 150 million euros. It's a campaign of what they call an aggressive campaign of deregulation. This is regulation. It is not really about child sexual abuse as far as the pushback. It's tech companies don't want to be regulated. They're pushing on this to stop this. They're going after GDPR, trying to weaken that. So any bit of regulation which is pushing back on American tech companies is being pushed against. So what is actually the CSER? It's not chat control. There is no chat related to this. It's to prevent the upload of known and unknown images and videos of children being sexually abused. So at the IWF, one of the services we run is something called Report Remove. And it allows children to upload their own abuse images to us. And they do this often because because they're being threatened, they're being extorted, and they're saying to us, could you please stop these images from being shared on the internet? So how do you do that? You turn it into a number, you put it in a database, you put that, then you ask these companies could you please stop these images being shared? And at the moment it's voluntarily, and many of them do not do that. So the moment we go back to these victims and say, well, we'll try and do this, but we can't do it on WhatsApp because they won't do anything. We can't do it on Signal, can't do it on Facebook Messenger. At what point do you put to the children, I'm sorry, but you have to live with child sexual abuse imagery being circulated around the internet forever? They'll die and their content will still be circulated. This regulation was an attempt to make companies do the bare minimum to stop the sharing of child sexual abuse. I would be happy to discuss further if anyone's interested on this. This is one point of view. There are other points of view. As a research group, learn more about this, learn that there are other points of view, come to your conclusions, hopefully, but a more well-rounded approach. And again, happy to talk to anyone.
Thank you for the question, Dan. I think it's really great that there are these things. I said it in my presentation. If they removed the mandate, they would have had 5 years ago, would have had some really, really common sense regulation in place. But because they won't give up the mandated scanning, every single other thing in this regulation also can't get passed. So it's a problem, no? I agree. I agree.
So when we say to the children, can you stop my sharing, the sharing of my imagery, do you ask companies to voluntarily do that, or do you mandate it? And actually, when we saw with Facebook,
yes, there
Facebook
already
Messenger
exists, and they still
were
have
voluntarily
the
preventing the upload of and sharing of child
Can we
sexual
move
abuse, and they
on?
chose
I
to
can't.
stop.
It's hard for me to moderate as the speaker, but I don't think this is productive.
We'll have to have this be offline, but I think we got a little bit more.
Thank you.
Other voices heard from. Sarah, you're up next.
It's so this is a slightly different perspective. I was wondering if you could talk from a civil society point of view. One of the things I understood that happened was that once, I can't remember which country it was, but once some of the politicians started understanding the danger of false positives of this scanning, they actually included clauses to exempt government employees from such scanning. And that's, to me, sets a really interesting double standard for this. And I don't know if you have a take on that.
Yeah, I mean, I think this is it's been interesting to watch the conversation evolve. In the US, I left the US out. It's not because the US hasn't had its moments with trying to backdoor encryption. It's that right now in the States, the conversation is around how can we create positive protections for encryption, because it's really clear that you need it, strong versions of it for government use. And so I'm hoping for the day when I can come to PEARG and do a whole policy presentation on ways that people have figured out how to protect strong encryption. We're unfortunately not there yet. I don't think exemptions is great. I don't think that's what we want. I think we want the democratic accessibility of strong encryption for everyone, not just those most powerful. I think that's a real key feature of the ubiquity of end encryption today.
Thanks.
Let's keep talking. And then Andrew, a short question.
Yeah, okay, I'll make brief comments. Okay, so in my view, I mean, there's a lot of misinformation on this topic. So for example, the position as described in recent IETF sort of publications and so on hash matching and client-side scanning, I think in my view is quite debatable. So for example, false positives in practice have not proven to be a problem over, I think, a couple of decades in practice. When we have throwaway sort of points about suggesting that this is the victims are a sort of a small minority, to give some scale, it's about 300 million children a year, about 40% of children globally. So
yeah, I didn't have any stats I didn't say anything.
Yeah, I realize that. So I'm just trying to give context for the audience, Mallory. And frankly, voluntary is lovely, but we know from research, and there's an enormous sample size to this, how I can put links later, end-to-end encrypted messaging platforms are the distribution method of choice for pedophiles in sharing at CSAM. So if we rely on voluntary, then the top three platforms are WhatsApp, I think Telegram and Signal. If we rely on them volunteering, then the problem isn't going to go away. So, I think we at least need to have a fact-based discussion would be my recommendation.
We wanted to get a sense of the kind of interplay of the policy and the technology and research. Right. And this is not a forum where we can discuss the big global, social reasons. And of course, that's not outside everybody's interest, but privacy research.
But can I respond about the perceptual hash matching? Because I too don't think that's a durable argument against. I mean, I definitely think that presentation from 122 is worth watching for people who want to understand what is client-side scanning and why has it been such a compelling idea? Because it obviously from I think, an intuitive approach. It seems like a terrible idea, but it's really caught on. And there are a lot of politicians convinced that it is the magical thinking that they've been waiting for. It's because of this perceptual hash matching. But I like knowing a bit about how it works and seeing a lot of these papers out there. The tech will continue to get better. The perceptual hashing is just an optimization goal. So in terms of pushing back against why breaking end-to-end encryption would be a tragedy for a lot of reasons, I don't think that perceptual hash matching being bad is a durable counter argument. So I agree, actually, Andrew. I think, and I think it's a really useful tool because there is so much of the internet that is not end-to-end encrypted, and I think there's still so much to be done there. Still. And, there's a lot of studies that show, even in broad daylight, wide open, plain text, unencrypted, anything, there's just loads of activity that's just not getting actioned. It's not getting addressed. And regulations like this would really help that. But again, it keeps getting hung up on this one thing. Like, do we have these really strong privacy preserving tools where you can have an actual confidential conversation on the internet? Should we just break that all the time for everyone everywhere?
All right. We're the better for all this knowledge. Thank you so much. Our last very brief it's really just a taste. Gianpaolo Scalone is going to tell us a little bit about something that he talked about in a side meeting that we think might be an interest. This is a teaser for future meetings. So like about 3 minutes, just give us maybe a little pineapple pizza.
First, thank you for inviting me to talk here. So I'll go maybe straight to the issue. So now I'm looking at the problem from a different perspective. So not the privacy from the destination, but from the destination access, but from the sources. What is happening with the ECH, for example, is that there is a new middle box that is the client-facing server. It is hiding the destination address, but in reality, it has also visibility of both client and destination and can do correlation and profiling. Now, this is a gap as it has visibility on a very large, the anonymity set, in reality, it is not anonymous for the client-facing server, but is a new profiling point that has planetary view. And there is also jurisdictional mismatch because the CDN is in a different jurisdiction respect the country of the user or the country of the content. Now I'll go to this scenario. Talking about this scenario today, I'm a bit guilty, as this morning instead of an espresso, I took a dirty chai latte. So I don't know if I can talk about it. But let's talk about Don Gennaro, that is a very famous pizza maker, but also as a high financial acumen. He started doing financial speculation, and then he take control of a major CDN. And he started implementing encrypted client law at planetary level to deploy ECH and have a bigger privacy. In reality, he wants to have mass surveillance and do user profiling, which is his purpose. He wants to divide the world population in pineapple pizza lovers and detractors. So he started a global profiling campaign and categorize user based on their preference. So world is now divided into groups.
Giancarlo, since we're at the 2-minute mark, maybe give us just a very high level. Why should they read these slides, and what can they expect to hear when you're back here next time?
Sure. So at the end, the issue is clear. There is the possibility to border control access gating based on preference. What is disclaimer? Don't want to offend anybody, and pizza lovers, either pineapple or not, enjoy all the respect. But how can we proceed? What I think is that as there is the client-facing server that is protecting the destination, so creating anonymous set, I think on the source, and the source I mean the edge of internet, where the internet addresses are assigned, that is the ISP or enterprise access edge. We need to implement something that can preserve source privacy. This something, I'm calling it customer-facing relay, and there is some accent on the word customer because there is a contract from the user, and there is also the possibility to change the contract because the contract is binding and strong. So if the customer wants to have more privacy or less, can decide. The purpose is to avoid new proxies. I'm spending really a lot of time removing proxies from network. Proxies are new surface attack, and I think is needed to remove, and no extra ops, so no additional delay. They have to be economically sustainable for deployers, and they don't have to change the protocol. So I'm not challenging ECH. ECH is here. This is another thing that will not touch ECH, will not drop ECH. And so next step is refine the architecture of CFR that, in my view, at the beginning is a sort of anonymizer of NATed IP addresses. So it will provide the customer a set of IP addresses for each target that belongs to the same client-facing server. I'm seeking here for co-authors, reviewers' feedback and contribution for the community if you think that this topic is relevant. There will be a new mailing list, CFR. It is not yet ready, but will be ready soon. And for contribution, you can use the mailing list or contact me directly.
Thank you. Thanks so much. We appreciate everybody coming. We're at time, and we want to discuss in the mailing list some of your reactions to this as a potential new topic, and also, of course, we'd love to see the mailing list energized. So please talk there, and thank you so much for coming. I'm not giving a chance for questions because we really want to let people get to lunch so they can go have their pizza or not, whether with or without pineapples. But thanks so much for bringing this up with
and
us.
thank you for inviting me.
Yeah.
Thanks all. Bye.
Yeah, I just wanted to thank the chairs for organizing this very interesting meeting. I think it went really well, and thanks everybody for the good presentations.
Oh, thank you, Dirk. That's good. Okay. All right.
Great job, Allison.
Yeah. See you guys.